Today we're continuing to talk about hydrocarbon refinement. We want to understand how hydrocarbons get isolated from each other, and this time we're going to talk about the processes after fractional distillation, particularly cracking and solvent extraction. So we've got a variety of different ways that we can further refine hydrocarbons once we've separated them out by their masses. Solvent extraction is a way to selectively dissolve chemicals in crude oil, and often we actually use this to remove impurities. So this could be as simple as just cooling a mixture off, which we call dewaxing, and that can cause large compounds, which is what we get waxes from, to solidify on the surface and be removed. If you're big into cooking and you've ever cooled off something and then removed the fat off of the top, that's pretty much what dewaxing is. It's actually the exact same process. We're just doing it with food instead of fuel. You can also do solvent extraction to remove any ionic compounds that might get mixed in there. Since those are water soluble, and of course water is going to separate out from the hydrocarbons, you can actually mix them in water and then allow them to separate, and that should pull out the impurities with it. Cracking is then a process of breaking down large compounds into smaller ones. Like, you might not want to have a 20 carbon hydrocarbon as your fuel. You might prefer to refine it down into propane or into butane. And that is exactly what cracking does. It breaks those large hydrocarbons down into smaller ones. The big ones can have their purposes too, but it's not always what we want. This process gets controlled using catalysts, and the point of the catalyst is to break down the products in a controlled sort of way. So you can kind of predict what you're going to get, and then you can separate them out by size using a fractional distillation process. Hydrocracking also combines this with a process called hydrogenation, and hydrogenation adds hydrogens into double bonds and triple bonds. So you can turn large alkenes and alkynes, which we don't often use as fuel, into alkanes that can then get cracked apart into propane and butane. There is a special type of cracking, though, that we call ethane cracking. Ethane cracking is actually the opposite as hydrogenation. This is actually when we pull hydrogens out of ethane in order to turn it into ethene. This is what we will call an elimination reaction in a later lecture. So we remove two hydrogens out, one from each carbon, and that's important. It has to be one from each carbon. And what that does is that creates some electrons on the carbons that are now unbonded. And what do they want to do? Well, the easiest thing to do is for them to snap right together and create an ethene molecule instead. We can also refine compounds through the processes of catalytic reformation, and that sounds very similar to what you would think, where you use a catalyst to reform the hydrocarbon. And this usually refers to the process where we take an aliphatic, unringed molecule, and then we ring it around into an aromatic benzene. And this is done because benzene, while it is toxic and carcinogenic, does burn very cleanly and very efficiently, so it makes a great fuel. And for similar reasons, we'll also sometimes turn compounds into branched compounds through a process called alkylation, in which we use catalysts to rearrange the molecule so that it has branches instead of just being straight chains.